multiplying and dividing, long division, adding and subtracting with like and unlike denominators, complex fractions, solving equations including verbals and extraneous roots of equations, and solving inequalities. Multiplying rational expressions. The product of two rational expressions is a fraction whose numerator is a product of the given numerators and whose denominator is a product of the given denominators. For example, p over q times r over s equals pr over qs. Example number 2. Multiply the numerators of the fractions and the denominators of the fractions. Then, factor the numerator and the denominator. Note that the factors of 5b plus 15 are 5 times b plus 3, and the factors of 3b squared plus 9b are 3b times b plus 3. Reduce the resulting fraction. Dividing rational expressions. To divide two rational numbers or rational expressions, multiply the dividend by the reciprocal of the divisor. For example, a over b divided by c over d equals a over b times d over c equals ad over bc. Multiply the dividend by the reciprocal of the divisor. Then factor each polynomial. Lastly, reduce if necessary. Adding and subtracting rational expressions with like and unlike denominators. To add or subtract with like denominators, add or subtract the numerators and keep the denominator constant. To add or subtract with unlike denominators, use the LCD as the common denominator and add or subtract the numerators. For example, x plus 2 over x plus 2x minus 5 over x equals x plus 2 plus 2x minus 5 over x, which will all equal 3x minus 3 over x. This is an example of a fraction with like denominators. Example number 2. This is an example of a fraction with unlike denominators. 1 over 5 plus 2 over w have two different denominators. So, you multiply 1 over 5 by w over w and 2 over w by 5 over 5. After doing this step, you will get the common denominator 5w. You will now have w over 5w plus 10 over 5w, which equals w plus 10 over 5w. Long division. This is a side note. When dividing polynomials, arrange terms in decreasing powers of a variable and use 0 as a coefficient for any missing powers. In order to solve a long division problem, you must first figure out what to multiply the divisor by. In this particular problem, you want to get rid of 2x cubed. So, you multiply x minus 5 by 2x squared, which will give you 2x cubed plus 10x squared. The two 2x cubes will cross out, and you'll be left with negative 14x squared plus 10x squared, which will give you negative 4x squared. You will then bring down to 21x. You will now have negative 4x squared plus 21x. Because you want to get rid of negative 4x squared, you will multiply x minus 5 by negative 4x. When you do this, you will get negative 4x squared plus 20x. Next, you'll subtract negative 4x squared plus 20x from negative x squared plus 21x, giving you x minus 3. You will now want to get rid of the x in the x minus 3, so you'll multiply x minus 5 by 1. Once you subtract the x minus 5 from the x minus 3, you will get a remainder of 2. Your final answer should read 2x squared minus 4x plus 1 plus 2 over x minus 5. The x minus 5 is the divisor. Complex fractions. Complex fractions are fractions whose numerator and or denominator contains fractions. In this example, you have 3 over 2 plus 3 over x, all over 2 plus 4 over x. Clearly, they do not have the same denominators. You will need to find the least common denominator, which in this case is 2x. Because the fractions do not have the same denominators, you will need to multiply 3 over 2 by x over x, and 3 over x by 2 over 2. Also, on the bottom, you will need to multiply 2 by 2x over 2x, and 4 over x by 2 over 2. After you multiply accordingly, you will get 3x plus 6 over 2x all over 4x plus 8 over 2x. When dividing fractions, you need to flip the second fraction to multiply. So, after you flip, you can cross out the 2x's. This leaves you with 3x plus 6 over 4x plus 8. You can now factor out a 3 from the top, which gives you 3 times x plus 2, and a 4 from the bottom, which gives you 4 times x plus 2. Since the x plus 2 in the numerator and the x plus 2 in the denominator will cross out, you will get a final answer of 3/4. Solving equations including variables and extraneous roots of equations. The equation for solving a work problem is rate times time equals work completed, which equals 1. Katie cleans a room in 4 hours and Sean cleans a room in 2 hours. How long will it take for both of them to clean the room together? This is a work problem, and we already know the equation for work problems, which is rate times time equals work completed, which is 1. In this problem, Katie's rate is 1/4, while Sean's rate is 1/2, and we're solving for x, which is time. Since you have two different denominators in the fraction, you have to find the least common denominator, which in this case is 4. After you multiply both sides by 4, you will get x plus 2x equals 4. Then, you get 3x equals 4. Lastly, x equals 4 over 3. It took Katie and Sean 1 hour and 20 minutes to clean the room. An extraneous root of an equation is a root that is introduced into an equation in the process of solving another equation, but is not a solution of the equation to be solved. This problem is an example of an extraneous root problem. After you figure out the common denominators and solve the problem, you end up with the answer as y equals 2 and y equals 3. However, 3 cannot be a solution because it makes the original equation undefined. Solving inequalities. When solving inequalities, you simply factor the polynomial and solve for x. Then, you should make a number line like the one shown above. Your number line will help you determine your solution set, which will be x is less than -1 or x is greater than 2.